Hi, this is Professor Stugard, and in this video we're going to talk about some of the introductory things that go along with doing text analysis. So our goals for this lecture, we're going to discuss what it means for a data set to be tidy if we're doing text analysis, and what we mean by the term token. We're also going to talk about what a stop word is, and how we can remove that from our tidy text. And really the overall goal here is just to understand how we can take text and tidy it up and put it into our data frame format so that we can do analysis later on. So let's start with reviewing what it means for data to be tidy. So if you remember, when we talk about tidy data, every variable has its own column, every observation is its own row, and every value is one of those observational units in our table, right? Every value is an individual value in our table. When we talk about tidy text, we are talking about a table or a tibble or a data frame where we have one token per row. All right, so what does token mean? Well, a token is just a meaningful unit of text, such as a word. Well, usually a word. Most of the time we're going to talk about a token as being just a single word. But it's the part that we are actually interested in for analysis. And then when we do tokenization, that's our process where we take text and split it into the individual tokens. Now, for text mining, we want the token that is stored in each row to, again, typically be a single word, although you can actually do it by sentences, by paragraphs, or really any length string you want to use. Now, for this, we're going to be using the tidy text package. This is separate from the tidyverse, and we're going to see why the tidy text package is so incredibly powerful for doing text analysis and the great functions that are included in that particular package. So, let's take a look at an example and see how we can clean up some raw text to make it usable for data analysis. Now, we're going to assume that we've already loaded tidyverse. That's basically a given at this point, but we do want to make sure that we install the tidy text package and also load it into our library for use so that we can make use of its wonderful functions and data sets. So, what I'm going to do, we're going to take a look at the first stanza from one of the classics of American literature by Emily Dickinson. Because I could not stop for death, he kindly stopped for me. The carriage held but just ourselves and immortality. So this is the first stanza of Emily Dickinson's famous poem. That's what we're going to be analyzing because, well, I mean, it's small enough that we can see what's going on here, I think, at each step. And again, typically, again, we might have our data stored in a bunch of different ways, but in this case, we have the poem stored in, well, the variable poem as a character vector with 4 separate strings. So we have one string for each of those first 4 lines. And again, if we were to actually check what's stored in poem, so again, line 1, because I could not stop for death. Line 2, he kindly stopped for me. Line 3, and well, so on. So again, we have each of these as separate lines. Each line is its own individual character string in my character vector for poem. Now, what we want to do text analysis is actually make this into a data frame, or what we really want to do is turn it into a tibble. So again, we've been using data frame and tibble pretty much interchangeably because they're fairly similar. Tibble is a little bit better. It is the more kind of updated version of a data frame that uses all of the tidyverse functionality. So we're going to create our data frame, but we're going to actually create it as a tibble. And so we have a function called, well, tibble that creates a tibble, or our data frame. So what I want to do is, again, take this poem and I want to store it as a data frame. So again, I have the poem stored as just a character vector. So I'm going to store it as poem_df so that I know that it's the poem stored in my data frame format. And the way I'm going to do that, I need to create my tibble. So I take my tibble function, and then what I need to do is define what each of the variables are going to be in my tibble or in my data frame, because that's really the key there. What are my variables? What are my columns going to be? That's what I need to define. So my first column, my first variable in my data frame, is going to be which line from the poem each thing comes from. So my first variable in my first column is going to be the line, and we have this format where the name of the column comes first, then the equals, and then the data. Now, in this case, I know that the poem is 4 lines long, or at least the stanza that we're using. So I can just use that nice, neat colon operator to say, well, the lines are going to be the numbers 1 through 4. All right. So I'm going to have a column called line that tells me which line of the poem everything is from, and that's going to be the numbers 1 through 4. That'll be my first variable, or my first column in my data frame. And then my second column is going to actually contain the text of my poem. So I'm going to name that column text, and the data is going to come from, well, the poem that I have stored as my character vector. All right. And so when I run that code, and I store it in my poem underscore df for poem data frame, we can see that when I run that function and I check out what's stored there, I have a 4x2 tibble. I have one variable for the line, which is the numbers 1 through 4. And we can hopefully see that those are all the integers 1 through 4. And then I also have the text of the poem. And again, each line of the poem now is on its own line. So I have the poem nicely stored in a data frame where I can see which line is which, and it has the poem and it's in my data frame form, which is nice. That's a good first step. Except this isn't compatible with my tidy text analysis yet. Remember, I want to do a few things. First, I'm not going to be able to filter out words because they aren't stored as words, right? Each line is that long character string, and R does not naturally recognize the difference between words because R does not see that white space, the space, as anything other than a normal character, like the letter A. So we're going to have to absolutely split this up. We're going to have to split each of those lines up into its individual word components because those individual words become our tokens. And I want one token, which in this case means one word per row in my data frame. So I need to take those lines and I need to put them into their own rows, which means I need to pivot longer. I need to make my data frame longer. Now, the nice part is that the tidy text package includes functions that do this for us really, really, really easily. So I'm not going to actually use the pivot longer function. I'm going to use the unnest tokens function, which comes with tidy text, because that's actually going to pivot longer for me in a much, much easier way. All right, so what I'm going to do, I want to overwrite my original poem in the data frame format by taking my poem in the data frame format, and again, I want to unnest it. So unnest tokens and my arguments. So the first one is going to be the unit to unnest by, and again, that's going to become my new column, right? So basically collapse it, right? And that's going to be my new column. We're going to separate it out, and then I need to specify, well, what was the original column that I want to unnest? And again, I had stored that in the column titled text in my original data frame. So when I run this, here we go. Now my new poem stored in the data frame format, instead of having 4 lines, I now have 20 rows where I have each word as its individual, on its individual row. And here we can see, because I could not stop for death, right? Each word is on its own row, so there's one token per row, which is what we want. And it actually did preserve the line that it was on as well. So I know that because I could not stop for death, those all come from line 1 of the poem, so that was preserved as well. Now, when you take a look at this, you might notice a few other really, really nice things that just happened when I used that unnest tokens format. Namely, it put everything in lowercase, and it removed the punctuation. I don't know if you noticed at the end of each of those lines, there was a hyphen at the end. Because I could not stop for death, hyphen, well, it removed the hyphen, and it made everything lowercase. And so the unnest token here really did 4 functions for us all at the same time. It split the strings, so it took the string and split the string into its component words. It made everything lowercase. It removed all of the punctuation in the white spaces, and it pivoted it longer. So we got 4 functions done all by just using the unnest tokens function. And so that was really kind of the person who wrote the tidy text package to put that all together for us. because now I can do some text analysis. Everything's lowercase, which means my filters will work the way I expect them to work. There's no punctuation left, so I don't have to worry about that. I have one word per row. This is all looking really, really good so far. Now, the last thing we really want to do to clean up our text, usually, not always, but again, this is something that we typically want to do fairly frequently, is remove the most common words in the English language. We call these stop words because, again, everybody has to use those words, and they really typically don't give us an insight into the text or the author or whatever it is we're looking at. Everybody has to use the word the, right? And so the is one of the stop words. Now, the tidy text package contains a data set with a bunch of stop words. In fact, it contains 1,149 different stop words. And if you want, again, when you load the tidy text package, you can obviously just type in stop words and check it out. And you can kind of look through all the words if you want to. But again, it does remove the 1,149 different stop words. Well, we're going to remove those 1,149 stop words. But again, those are the most common words that typically are not used for text analysis. The way we're going to remove them is what's known as the anti-join function. So what the anti-join function does is it looks at two different sets of values. In this case, it's going to look at two different sets of words, the words for our poem and the words in the stop words. It's going to look at both of them and compare them. And if a word appears in both, it gets rid of it. So if one of the words from my poem appears in the stop words category, it removes it. It kicks it out. That's what an anti-join does, which makes it, again, really nice for this type of analysis. So here's how we're going to do it. We take my poem that's stored in the data frame format, again, the one token per word, and I want to anti-join it with my stop words. And again, because I loaded tidy text, the stop words, that data set's right there. So when I run this now, it removed all those stop words, and before, where I had the poem separated into 20 rows, there's 20 words, now that it removed all of those stop words, all those really common ones, I'm only left with the 7 words that are not commonly used in the English language. And the nice part is it actually still preserved which line they appeared on in the poem. So again, remember the poem was because I could not stop for death. Well, because, stop word, I, stop word, could, stop word, not, stop word. Those are all very common, so we removed all of those. And so all we're left with is stop and death from the first line. And you can see that we went through and did the same thing with those other lines as well. So now, again, I took one stanza of this poem, I put it into my data frame format, I pivoted longer, I have everything lowercase, there's no punctuation, and now I remove the stop words. Now I can start doing different types of analysis. Now I can start wrangling or comparing or making visualizations. This is really just the first step in cleaning our text up for analysis. And again, we did a very kind of simple example here, right? Just one stanza of one poem, but you can actually do this on entire novels, and entire bodies of work, as long as you have it in the R environment. All right, so again, here's my original, because I could not stop for death. This is what we started with, and then by doing those few different operations, which took just a couple of minutes, we took that whole poem of text and put it into my data frame format with only the 7 most uncommon words, which will let me do different types of analysis. Now, typically when we do our text analysis project, this is really the beginning step. This is that first step where we take our text data, we use our unnest tokens function and the tidy text package to make it tidy. Now, once it's in that tidy format, we can, again, try to do a few things. We can still try to wrangle it depending on the data set. Again, there's different things we might want to do depending on the context. But then typically what we want to do is take that text and summarize it somehow, come up with some summary function. So again, typically count, right? How many times did they use particular types of words? We get our summarized text, and then of course the beauty is then we make our visualizations. That's really the end goal with almost all of our projects. How do I take a novel and reduce it down to a nice, neat visualization that hopefully everyone can understand? All right, so that's going to wrap it up for this video. Again, start playing around with this, and we'll talk about different types of analysis we could do at other points. But for now, we want to focus on first of all, well, what packages should you install and load to do your text analysis? And again, typically we use the tidyverse. What's the other one that we want to include if we're doing text analysis? Number 2, what do I mean by a token in text analysis? So what is the actual definition, and then what do we typically choose as our token? Next, what is the text analysis version of the pivot longer? Right? So what was that function that we used that not only did it pivot it longer, it did all of those text-based things for us, like string split, lowercase, string to lower, and string replace. What was that called again? Because that's the really useful one that we want to use. And then lastly, what are stop words? When I say stop words, what does that actually mean? And then lastly, how do I remove stop words from my tipple? All right. Well, hopefully we can answer all those questions, and hopefully we learned some things today. And as always, take care of yourselves.